Hello and welcome back to another Python chatbot video. Today we'll be talking about virtual assistants. Now, virtual assistants are chatbots which can help manage your life. So this can be through calendars or just asking questions like, what's the headlines in the news or anything like that. They're just very helpful to have around the house, and you may probably already have one like Google or Alexa. Now, they have inbuilt functions which provides their abilities. So this can mean having, if I say what is 2 plus 5, it's going to have an inbuilt maths ability to break down what I've said, work out it's a maths question, and then break down the numbers and the operators. So numbers like 4 and 5, and the operator is plus, so to add, and that's what it will do. So let's think about how this sort of thing will work. We will need to make sure that the system is able to break up your sentence. So the first thing you'll do is enter in your sentence. So we'll have our input, and that will go into the bot. So we're just going to call that bot. Now, what will happen is this bot will need to firstly break down the language. So what are the components of it? So we want to say we have what is your name. Apologies for the handwriting. So I'm just using my finger. What is your name? So we have a what is question, and we're discussing your name. So we want to be able to split down these sentences. If I was to say, what is 4 add 5? I want to split down what is and 4 add 5. How many roads must a man walk down? So how many roads perhaps, or just how many actually, and roads must a man walk down is you'd split down. So it's not just about dividing them in half, but it's about breaking down where sentences no longer really continue a meaning. So if I was to say, could you fetch me an orange and a pear, it would be maybe, could you fetch me an orange and then separate pear. So that would break up into 3 separate components. So that's what it will be about, is essentially just breaking down what a sentence is. So I'll just keep the first one. Now we can do this using tokenization, which is a part of Nltk, the Python language library. So we can do that by looking at what components is each, researching through. So this is where research comes in, researching where sentences tend to end in meaning. So perhaps with an adjective, if I was to say, could you get me the sizzling sausages? Could you get me? And then sizzling is an adjective, or even a noun as well. We might break up at nouns that, well, I'm talking about sausages, don't need anything before. So it will be just researching through where sentences tend to end and breaking it up. So that'd be the first step. The next step is to classify what this is. Now we can use different methods. We could use things like naive Bayes classification and all sorts of mathematical classification models. Or we could do it quite simply and just write, if these words are found in here, are found in this sentence, it's going to be this. So if we want to classify whether it's a maths question, so what is 4 plus 4, or whether it's a time question, so what time is it, or what is the date today, whether it's a calendar question, which could be what do I have tomorrow, or what's going on the 26th of February, sort of thing. And we might just have a standard question or a standard statement. So what will we want to do with each of these, and how will we classify it? Well, we'll have lists of words, and this can be used for any sort of classification where you could have lots of positive words like happy, great, excellent, and when you put a sentence in, if it contains things like happy, great, and excellent, it's likely to be positive, and if it contains something like bad, terrible, awful, it's likely to be negative. So that's what classification essentially is. There's so many different models. This is a very simple model that I'm talking about, but you can just take a word, check if it's in something, and try and see if the probability is higher that it's positive than it is negative. And if it's neither, it could just be a neutral sentence with nothing positive or negative about it. So that's what we'll be doing. We'll be writing lots of maths words, so that will be numbers, and we'll use number normalization, which is a method of turning things like 1 plus 2 equals 5 into num plus num equals num. We're just replacing all with one single character which can represent number. Because although the numbers are significant when we want to actually apply the mathematical equation, it's not significant in the classification or processing method, because if we have to program in every single number, that's going to be infinite. So that's what we'll do for maths. For time, we'll put in words such as day and time and date. So if you say, what day is it today? What time is it? And then calendar, once again, it will just be tomorrow, or if we put in like months, like if we say February or January, because we will have some confusing between, is it a maths question or a calendar question? If I was to say the 26th of February, we'll find a number and think, is it maths? But then I say February and it thinks, but it's calendar. So we need to think about how we're going to select each of them and classify whether it's one or the other. A maths, time or calendar will always be a question. You're not going to make a statement really, or you could say, my God, what is the time? But then that wouldn't be a question. So we'd need to be a question if we want to find out what the time is. And then if it's none of those three, it's going to be a question. And we could build in our own questions. So we could have the name of the bot, we could just call it chatbot. We could have the age of the bot and just information that you want the bot to know. And you could do the same for statement. So what it will do is, if it's found as a question because it contains words such as what, or can, or how, or when, then we'll classify it as a question. And if it's none of the top three, it's going to be a statement, or it's very likely to be. I don't think there's anything else it can be. And then once it's got the classification, then we can start looking at answering it. So say it's the maths, we'll obviously find a way of breaking down the numbers and the operators. Time, once again, it's the time, so we'll just get the time and date and everything. If it's a calendar, it'll be breaking down what date they've given, or if they said today or tomorrow, and then using a calendar, so I'll link it to my Google Calendar, and it will tell me what's going on that day. And the question, it will, as I previously said, it will have its own set data, and if it can't find that, it will use Wikipedia. So we'll use a Wikipedia library where we can just put in the subject. So if I said, who was Winston Churchill, it will find Winston Churchill is the subject of that piece of text, because who will doesn't need to be put into it. It will then just use the Wikipedia library to find information on Winston Churchill, and it will return it. And of course, if it can't find any information, then it will just say, sorry, I can't help you with that. As you may find like Alexa and Google, if you say something weird to it or something it doesn't understand, it will respond and just say, I can't help you. And then statement, it will just look through its data and then otherwise say, I can't help you with that, because there's not a lot you can do with a statement. So that will be the basic plan of what we're going to code. So let's get coding. Now, firstly, there's a few dependencies that this requires. It's the Wikipedia library. The Google API client I'm using for the calendar code that I wrote, and I'll put a link in the description to where you can download that. Also a link in the description to a tutorial on how to set up your calendar with it. So once you've watched that tutorial, you'll understand how to sort of integrate that into the code. And also, if you get any errors with this library, you may want to install this library as well. So that's just to think about, but only with this bot. We're using the Wikipedia, and you'd only want to use this if you're going to make a calendar. So what we're going to do, we're going to import the libraries. Oh yeah, and another dependency actually I should have added was the Nltk library. Pretty much what this is, like pip install Nltk, and then you'll want to import Nltk and download all the packages. But all this essentially does, as I spoke about before, is gives you the means to start looking at the natural language engineering. And some code to download. Here's a link to the downloads on my website, but I'll post things in the description. You'll need to create your own Google Calendar key, and here's the tutorial here, but it'll all be in the description, so don't worry. Right, so we're going to import Nltk. Then we're going to do from my calendar. So this is just some code that I wrote and put in the same directory as what this is. So I'll just load it up. So here we have the API client discovery, the Google authentication flow, and all sorts here. And pretty much it's just a class calendar, and you could put in your own token if you've got one, but like as an object. But I might just use Pickle to save the token that I created using this. But you can do it in your own time if you want to use the calendar. But we just need to pay attention to get day, where you put in as a string the day that I want, or the date that I want, in the form that day, month, and year, all in a space, so like this format, and then get events, which will just return all events. But we're going to be using get day within our code. So from my calendar, import calendar, and then we're going to do import Wikipedia. Then we're going to do import date time as dt, and from date time import date and date time. Now this can get a bit confusing having all these different date time things, but I've imported this bit as dt and everything else as date and date time. You don't need to worry too much. These are just different elements of the code that we're going to be calling in. So we'll be using, as I said, Nltk for the natural language, but the calendar for the calendar, Wikipedia to do searches, and then we'll be doing date time and the date and this date time, all just for finding the date, finding the time. Well, I mean, I guess it does what it says on the tin. So class chatbot. So this is what we're here for, making a chatbot. Now, we're just going to be simple about this. We're not going to go through every avenue and find every possible way that it can answer different questions. But this is going to be a simple chatbot, and it's going to be a virtual assistant. So as you probably know, if you've done some object-oriented code with Python before, we don't have to, but if you want to have an initializer, you write it like this. We don't need any parameters. If you wanted to have parameters, like you can put in a name and it will always know its name, you could do that, but we don't need to do that. So in here, what we're going to need. So the chatbot will have certain words that it's going to understand. So it's going to understand a question, say so we did self dot question, and we could have just a list of words, which if that appears, it's probably going to be a question. So like what, when, why, who, there you go, where, and why. Then, oh no, we've done why, it would be how, and also can, if you like, can I have, but also could be considered like a watering can. So that's something that you'd want to be careful about. If we was to go more in depth, we'd use all sorts of syntactic analysis, but we're not going that far into it. This is just a simple chatbot. So we've got questions. We want to define whether or not it's a question. We want to see what sort of question. Are we asking about maths? Are we asking about the calendar? Are we asking about the time? So let's do self.maths terms. And this is just going to be plus divided minus add square root squared And we could also just go down here to make it easier. Then what else will we have? Well, I guess divide, although we've got divided, but we'll do divide, subtract, multiply, add, add, times, num as well. So we're going to put a num because we'll want to break down a maths question into, because if I put every number in there, it's going to be stupid, because I can't put infinite numbers in there and it's like, oh, if this number is in there, I'm just going to put num and I'm going to convert all numbers to num through the code. But we don't need to worry too much. Multiplied, and then we're going to have a subtracted, because if you had like subtracted from. So there are maths terms. There may be more, there may be less. Well, no, there's definitely more, but we're just going to make it simple, and we're going to put in the maths terms that we know. And there's all sorts of methods of gathering this. You could use classification models just to find all words relating to maths, but I don't think it's necessary for this, because it's just going to be simple. So we also wanted to tell the time, so we could do time terms. So this probably just be, so what is the time, what date is it today, and what day is it. There might be more, but we're just going to go with that. We also want to know the months, have a good understanding of the months, and this will January, February, but this is just to give it a good understanding of, I need it in order as well, so it will be able to locate it, because if I say what is the 4th of February, what do I have on the 4th of February, we'll check the calendar, but the calendar takes it as an integer day, so the first month or the second month, so we'll need to make sure that we've got it in order so we can take it from there. And also then we can just add this into when we write our calendar terms. So April, May, and notice that I'm doing no capitals. That's just so I can convert everything to lowercase and not have any case problems. So October, November, December. So there are months. So if we start to do calendar terms, we'll want to do self.months plus, and now we can start writing our terms. So let's think, what would we want? So what is happening on the 25th of December? What is going on the whatever? We'll put going on, because going could also be something else, that I'm going to bed. Then what's in the calendar? Then I guess you have Monday. What's going on Monday? What's going on Tuesday? What's going on Wednesday? And so on. And let's think, is there anything else we could have? I guess what's happening today and what's happening tomorrow. We're not going to worry too much about what's happening in 3 days' time. It'd be a more complex bot to do that, just more code really, but we're just making it simple. So we've got our maths, we've got our time, we've got our calendar, and that's what we wanted the bot to do. We also want to define, so if we do self.calendar equals, and then calendar and this is going to call in our the library or the class that we wrote within here. So, and then below we're just defining keywords. So this is what we're going to use to classify what a sentence is. This is a very simple classification model that we're using. Now, if we wanted to give it its own question, so maybe, because if I was to say, what is your name? You don't want it searching Wikipedia for that. So we could do self.questions, and we're going to do this as a dictionary and look for phrases like your name. So if you ask a question about someone's name, it's very likely to be a name. So my name is chatbot. In fact, we could even do name, and you can say my name is, and then that's name, and that means that you can name the bot when you call it in. So next it might have what is your age? I was made on the 21st of the 1st of 21st. Then we could have what else is there? I mean, you could say anything really. How are you? And I am good, thanks. You could just fill this for ages. You could write this all in a JSON file as well, or you could have a JSON file of conversations and just use it to train it on. But this is just a demonstration, but you could use anything. And then we could do the same with statements. So I don't know, I like you, thanks. And you could just go on for ages with that. So let's go back here. So that's just going to initialize. It's going to initialize all the questions we want, and it's going to create a calendar client. Now we're going to have the natural language part of this, so we call it breakdown, and this will break down our sentence. So we're going to enter in a sentence. We firstly want to just get it in lowercase, so we can compare it with things. Sentence equals sentence.lower. Then we will want to tokenize it. So tokenizing is pretty much just splitting it to, we're using Nltk. It's like .split, where you split it into words, but it goes a bit further to tokenize sometimes punctuation. So tokens equals Nltk dot word tokenize, and then I believe it's in brackets sentence. So that should split it down to tokens. And then we want to get the tags. So this is where it starts saying whether or not it's and we can have a look down here. In fact, so C equals chatbot, call it Brian, and then while true, print, and then I guess we'll just do breakdown, and then input. Actually, we'll do that on another line. It'll be c.breakdown, won't it? Yeah. So tags equals Nltk dot pos tag, and then in brackets the tokens we just created. So we could run that. Actually, no, we won't. We're going to do then just print tags. So if I was to put in, it might take a while actually because we're calling in a calendar, yeah, because I haven't got the I've got Wi-Fi at the moment, so the calendar bit won't work yet. But But yeah, so how are you doing? So how is of this type, so I believe that's like a what sort of question. So that sort of is usually associated with questions. I always find are you, so that's a pronoun, so on. I am riding my bike. Here we have bike, which is a noun. So nouns are basically the subject. Riding is a type of verb. So it essentially just splits it down. Interesting, it puts as a noun. Actually, no, yeah, I think it is. But anyway, so that's just how you break down the sentence. Now we want to start to break this up into, if I had what is your name, we want to have what is and your name, as I explained before. So what we're going to do is we're going to have your sub-sentences. This will be, it's just going to break up all the parts of the sentence, and you're going to have a phrase. So the sentence is made up of lots of phrases. This is going to be a string. So let's just loop through it. So for or we could just do for word, because you see it's a tuple of word and the tag. So in tags. So this is going to loop through each of the tags, and we'll do if so this will be tag equals VBZ. So this is just sort of a bit of research I did beforehand, but this is if like certain tags are present, it should split up. But there's going to be two types of split up. There's going to be a tag where it should form part of the sentence. So it should be at this tag we're going to split, but we're going to split after that word. And there's going to be some tags where you're going to split before that word. So if we have VBZ, which is just a type of word, you don't need to write too much about this. This is just some research I did, but you can play around. You could just keep writing out sentences, looking at what sort of tags are common where it should split, and then just writing it. But that's for you to worry about. So 4 plus, or you don't need to worry about because I've done a version of it. So we're going to add it to the phrase. The phrase is just going to keep adding all the different words. And then we'll have if phrase is not equal to nothing, then we'll do sub-sentences append, and we'll add the phrase. Whoops, there we go. So once that's done, we can wipe the phrase. So that will just add, so if it's been gathering all the phrases, that will add it and then append. So that will be stop adding to the sub-sentences after that word and then start again. Now what we could also have a tag being, so this is going to be a tag at position 0. We might have a W. Now a W is like a question, so what, when, why, who, where, whatever. So if it's a question, we want it to always sort of split after that point, just because that's just what I found when researching. So if it won't be, or if that, or the tag is an adjective. I found adjectives as well, quite common. Tag is, so if you're confused by this or think what's he doing, don't worry. This is just me writing down from what I did in research what tags are good to break up at. So or the phrase is not equal to, actually no, it's not that, or the tag is 2, or if we've got a new line, oh no we can't, so, or the tag is equal to I think a verb as well. Verbs are quite present, or the tag is equal to nope, here we go. So that's just some research I did, don't worry about it. But we're going to do the same as before, but instead we're not going to add the current phrase. So phrase is not equal to that, because we don't want just to add blank parts. Then we append it, and then phrase equals nothing again. Then what we can do is do a phrase plus equals, then it's going to be word plus space, and then here else, because we use an else and not just put it underneath, which would probably look more efficient because of this part, which will add and then split, whereas this bit here will split then add. You'll see what this all means in a minute if you are struggling. And also subs dot append phrase, this will be the last phrase there, and then return sub. That will probably do if phrase is not equal to nothing then. So now we can start to see what this does. So if I was to say, what is the capital of England? Name error, subs. Yep, there it is. Right, let's do this again. What is the capital of England? So, so we've got a bit of an error. Let's have a look. So we want to add what, and it's not adding that. So tags at 0 should find the what. So let's have a look. We'll print each tag and see why is it not adding. Oh yeah, we don't want tag, we want the word. Yeah. Okay, so it's going through and it's not adding what or is. So it should append, it gets to what W, and it's like, okay, append phrase, but it hasn't added anything, so it doesn't add anything. But then it should add that to the phrase and then go back. So why is it not adding to the phrase is the question. So it should be going through there. And so debugging is obviously a big part of code, and you can think you know that you've written something, but then there'll be something slightly off. So got the phrase, and we've got the phrase plus word, so let's print phrase there and see why has it not added it. Nope. Right. So what and of. So that's suggesting that it has added it. I honestly don't know. So if we were to do, actually no, that's just going to test the tag, we don't need that. So phrase plus equals word. Perhaps it's that, which I should have done a plus equals and not an equals. Let's have a look at that. there you go. Silly me, I put a plus and equals. I'll keep this in the video though, because I think it is good just to go over where you get stuck on things and how you sort of work it out. Because a lot of people do cut out their bugs and things from code, from like a video, and you know, it makes the video quicker, but it's sometimes good just to watch somebody go through the motions, and it may help. So as you can see, it breaks it down. So if I say what is the capital of Germany, as you can see, it starts to break down. So if I had more advanced bot, it could look at what is and capitals and Germany, and it would find information about that. So it is something to bear in mind when going through code and writing bots. So we've done that. Now the next part of our normalization or NLE process is going to be normalization. Normalize num. So we want to make sure that we remove numbers. This is going to be something that we use later on, but we'll do text equals text.split. So we're just going to split it down to its words. New phrase equals that. Then for token in text, if token is not equal to nothing, we don't want anything which is nothing, then we'll do if tk dot is numeric. This is an inbuilt function to decide whether or not a string, like if I had a string ABC, that's not numeric. If I had a string 37, then that could be numeric if you wanted it to be. So is numeric, then we're going to, we're going to just do new phrase plus equals num, plus, and then we'll do, in fact we can just do num and space, else new phrase. So if it's not a number, we will just plus equals the word that it is, and then we'll return the new phrase. So all this does is I'll also get rid of the last bit of it. We don't want, because it will add a space at the end, and we don't want that. So that will just normalize your sentence to be all numbers will just be replaced by none to represent it, I guess. So now we're going to do define get meaning. Now this is the classification part. So once we've done the breakdown of the sentence, we'll add in phrases. Now the phrases, obviously it's going to be like what is, and then the capital, and then Germany or something like that. And we will do question count equals 0, maths count equals 0, time count equals 0, and calendar count equals 0. So oh yeah, and then num found, because a number will be, we can't do, like we could find someone talking about adding and subtracting, but if there's no number, then it's not going to have anything to do with like actually working it out. So we'll do num found equals 0. So for phrase in phrases, so we'll search through each phrase within it. We'll have phrase equals self dot normalize num, and then phrase. So we'll just convert the phrase to having no numbers in, just num. Then we'll do for I in self dot maths terms. So this is the bit where we start looking through the terms that we looked at before, we created at the top in the initialization. If I in phrase, so if any of the maths words is in the phrase, then we will do maths c plus equals 1, and also if I equals num, then I in phrase, then we'll do num found plus equals 1. So what we've done two ifs, so this will basically, mathsc will always be bigger than num found, and that's what we're going to use to determine whether or not it's a maths question or whether or not it's a question about maths. Because if, say you have num plus num, that's what you're asking, what is num plus num, it will find, well, plus, we'll find num first and say, yep, num is in the phrase, so maths c increases by 1, and also I is equal to num, so num found equals 1, so we're both on 1 there. Then we'll have add, now that is in phrase but it's not num, so maths c is now 2 and num found is 1, and then we're going to have maths c increases, so that would be num, so yeah, that would be num again, so maths c is now on 3 and num found is now on 2. So that means that we can always find, okay, well, num found is not 0 and it's less than the phrases, the maths c, so it's likely to be a question. It's just sort of a bit of logic that I added in. There may be a better way of doing it, but as I keep saying, this is just a simple bot. So that's the maths classification done. So it's sort of just defining or calculating the probabilities. So if we do question terms, so let's find out if it's a question. If I in phrase question count plus equals 1, and these ones are a bit more simple than the maths one. There's no sort of double-edged sword or any sort of extra logic. It's quite simple. Then we will maybe calendar will do next. Calendar terms. If I in phrase, then we'll do calendar count plus equals 1. Then the last one was time. Yeah, it's time. In time terms, and then if I in phrase, and surprise, surprise, time c plus equals 1. So that would have classified or calculated all the different probabilities. So now we're going to go down in the order of actually deciding what it is. So if question C, if the question C is greater than 0, so it's a question or question words were found in it, and num found is greater than 0. Well, that should be and. So we know that there's numbers in it, and we also know that num found is less than maths count. So as I spoke about that logic before, this means that it's going to be a maths question. If question count is greater than 0, so we know it's a question, and calendar count is greater than 0, then we will return calendar question. If question count is greater than 0 and time count is greater than 0, return time question. And then finally, if the, or not finally yet, actually, if question count is greater than 0 but nothing else, so none of the others were found but it is still a question, then we'll just return a simple question, and then else we will return a statement. And then that's it. So if we were to play around with get meaning, so we'll do c.breakdown input and then c.get meaning. So if I start asking questions to it, what is the capital of Germany? Okay, so here we go, no attribute question terms. Yeah, because that should be self and no attribute question. Yeah, oh, I just did question. We'll call it question terms, just so it's in line with everything else, because that's obviously what made me confused. So what's the capital of Germany? So time terms. I thought that was one. Let's have a look. Time. See, I just wasn't thinking, was I? So let's try this again. Question. So it knows it's a question. It's not a question about maths. It's not a question about the calendar. What day is it today? Calendar question. So I said today, so it's getting mixed up there. So it's not completely accurate. We could go back and change that. What is the time? So this is a time question. What do I have tomorrow? It's a calendar question. What is 5 plus 7 add 9 divided by 2? It's a maths question. And look, I've used different words to do it as well. So yeah, so I'm happy with that. Oh, and if it's nothing, you are cool. It's a statement. So as we can see, it's, you know, I'm happy with that. The bit about today and day, we could go back and change that. A more complex classification model like naive Bayes, and maybe looking at some sense analysis and semantic analysis, that would probably fix that. But it's, as I say, it's a simple bot. So now we want to do just a function or a couple of functions we'll do before we get to our main sort of chat function. It's going to have check present. So this is just going to check the presence of a sentence in a certain data. So within here, we're going to get, maybe put our question in or our statement in, and we're going to see whether or not it's in there. So we'll do output equals that. So let's do check whether sentence is in data given. So this is going to be for finding our own, like looking for our own sentences. So we want to do for chunk in sentence. So we'll enter in here each like part of the sentence. Then we'll do for phrase in data. So we're going to loop through every single phrase in the data. If phrase is in chunk, then output equals data at phrase. Because remember, the data, if we go up, because this data is going to be one of these questions or statements, so it will get your name and then the output associated with that. And if it finds something that doesn't seem to be indented properly, return output. Is that indented properly? It doesn't look right. That's column 9 and that is column 10, so we'll go back to 9. Right, so there we go. We've got, that's just going to find whether or not we've already got the answer saved, and then we'll do a extract subjects. Extract subjects. So this is going to be used to find. So when we haven't found it and we want to just search Wikipedia, we're going to find just a sentence. We're just going to look through the sentence and find the subject being mentioned, and then go from there. Sentence equals sentence.lower. Then we'll do tokens equals Nltk dot word underscore tokenize, and then in brackets sentence. Then tags equals the Nltk, and then I think it's dot, isn't it? Yeah, pos tag, and then in brackets the tokens that we just created, and we'll do our subjects and a string of subjects, so we can, like, if there's multiple subject or like a name, so who is Winston Churchill, Winston Churchill will be two different words, two different subjects, but it will be the same subject, the only subject of that conversation. So for word tag, also that word and tag, in tags, so we're going to go through all the tags and get the word and tag separately. If tag equals subject or tag, so these are the two keys I found which commonly part of subjects. So s plus equals word and then plus a space, else s equals, we want to gather all the subjects, so if s is not equal to that subs dot append s, and then s plus equals, that's right. So what we'll do, if we find a subject, we'll add it to that. If we don't find a subject, we just add the subjects, because then we don't want one long subject of if you say my bike is green and it was saying that the bike and it being green, the subjects, we don't want it to be bike green because there's still a lot of words in there, so we're talking about bikes and green. After that, we'll just return subs. And also, in case there's one left, we'll do if s is not equal to nothing, then subs.append s, to make sure that any last bit of information is added. So that is all the sort of natural language that we need to worry about going up to it. So now we're going to do the main chat. So we've made all the tools basically to allow us to talk with it. But now we're going to do use it. So we'll have the broken data into the breakdown, and then we'll just put in our message. So now we've got our message broken up into something like what is the capital and of Germany. Then we're going to get our type. So what type of sentence is it? Self.getMeaning, and then use the broken data. And our output was going to start off as nothing. So now it's time to find it. So if type equals calendar question, and we'll just start writing things out. So elif, it's a maths question. Just write pass for now. Elif type equals is it a time question was one. I think that was it for the special functions that it will have. And then we'll do that if type equals question. So if it's gone through the others as well, and it hasn't found an output, then perhaps it mentioned time or maths or calendar, but it wasn't actually a question for them because, say, we can't actually find the structure. So it turns out it's probably just a question. So it said, what is time? It would think it's a time question, might not be able to find out what is time, and it would go to question. So output equals self dot check present bd. So that's going to check whether or not there is something. If output is still nothing, then we'll do subs equals self dot extract subjects. That's what we just made. And we'll put in our, I think it's, we want it as a string, or do we want it as, so I guess if it's going to loop through, then we'll want it just to be the message. We don't want to use the broken data because, yeah, we just want to loop through and check. Because chunk is just each word in the sentence, isn't it? At least I think so. Essentially, if we're just, yeah, I think that's right. Yeah, because we're just looking to see if it's in there. Actually, I do think that should be then sentence.split. If we're just going to put in a string, it should be dot split. Otherwise, it's going to give us the in the check present. Is, I don't know. We'll see. We'll see. I think that should be dot split, but we'll see. Right. So anyway, then once we've got the subjects, we're going to try get the output equals Wikipedia dot. So this is using the Wikipedia library. So we're just going to take the first subject. You could write a more complex program, but it's up to you. So maybe we could get the first, but we'll just get all of it. But then, yeah, you can start breaking it down to paragraphs if you wanted to by using dot split at \n. And otherwise, if we can't find it, we pass and output continues to be nothing. Now, if it's not a question, but obviously if we just do else and it's a statement, after it's done all of these, it will still go through it. So we need to do else output is equal to nothing. So if it's, that means that it hasn't found anything in these, or it wasn't any of them, and it is not a question, then it will go to this. And then we'll just do the same as this. But yeah, that should be check present and then self dot questions, shouldn't it? Because yeah, we have two different parts. So here we go, and we'll do self dot statements. And then once we've got that, we'll have if output is nothing, so it didn't find anything, we'll just return a message like, I am sorry, I can't help with that. Because sometimes you'll be talking to Alexa or Google and they'll reply, sorry, can't help you with that. So it happens. Our bot doesn't need to be perfect. So there you go. So let's start playing around with c.chat, and then I guess we don't need as many as these. Okay, so we got a syntax error. What have we done? So that's column 5, that's column 4. So go back one. Okay, we got a syntax error again. Right, let's have a look. So, yep, I deleted too many. So let's have a look. If I was to say, no, I don't have any internet, so the Wikipedia will not work. So we've got a split. So it's not a split. It means that the sentence is try that again. Okay, so if I said, what is your name? Will it tell me my name is Brian? There you go, I like you. Okay, so statements, we got an error here. It's up here, we called it statement. Okay, it seems weird, but I like you. I'm sorry, I can't help with that. So it's not finding that in statement, but that means it has gone to statement, just hasn't found. Oh, it could be that if we try that, thanks. Yeah, there we go. So it breaks it down to I and like you. Yeah, so that's good there, and then everything else that we haven't added in. So let's start with time, because time's going to be a fun one. So we want to get the time. If it's a time question, we'll just get the day equals dt.date time today, and dot week days, weekday. Yeah, so this is going to get us what day it is of the week. Now equals date time dot now. That's going to get us the time, and the date equals the date dot today. Now we will do output equals, make a nice message, it is, and then plus s string now dot, and then we're going to convert it to certain format, strf time, and then we'll do percentage hour, and then we want to get the minute. Then we'll do another one plus str, I think that's then d dot str f time, and we want that in the form of b, so that's the month, the day, and the month, the day, and finally year. I should want a space as well. Then we'll do plus, and this will be the final bit, str, and we want the day. So let's run that. What is the time? Okay, so today is not defined. Let's have a look. So you can see where we went wrong. That was a silly. Let's run it. What day is it today? I'm sorry, I can't help with that. Okay, that's annoying. It should be finding it. Oh, sorry, yeah, it's finding calendar, isn't it? What is the time? So yeah, it is 10:28, January the 21st, 2023. Let's put the number 3, which is weird. Oh, it's, I don't know, that's weird. Yeah, because it should be telling us weekday, shouldn't it? It should be saying it's a Thursday. But it's not. I don't really know what to do because that's somebody else's function of their code. So and that's weird. We're going to leave that out for now. You won't be able to know what day it is or weekday it is. We can go back to that at a later time because I don't want to spend loads of time. What is the date? So yeah, I don't want to spend loads of time on debugging something which isn't to do with me. I've probably just used the wrong command and it's not important. So we've done that. Maybe we'll do a maths question now. So we'll want to refine it, to do refined. So we'll want to basically get an array of number, operation, number, and whatever, and then perform the maths on it. So to do, we firstly just want to add. So this is going to store what the current operator is if we're going through the math. So if we do for I in refined, actually we'll do that in a minute. So for word in message dot split, and then we will do if word in message dot split, for word dot if word is numeric. So we want to find if it's a numeric word, then or word, and this is where we know that it is an operator if word in maths terms. So this is where we know it's an operator. We'll do refined dot append, and we'll add a word. So what that's going to do is collect an array of numbers plus equals, and we're not actually going to have it as num. We want the actual word, not num, and that's why we're not using anything like BD or whatever, or normalize number, because we want the actual number. We can't add num plus num. We need 4 plus 5 if we actually want to calculate it. So collect an array of numbers and operators. So once we've done that, that should have collected everything, and we'll have num equals 0, so that's the current calculation, and we'll go through each part of the refined. So output equals plus equals I, oh no, oh, what am I doing? Output plus equals, there you go, I plus, we'll have a space, so it's going to be like 5, or add, so it'll be 5, and then the next iteration add, next iteration 5, and then we're going to calculate, and at the very end we'll say is this. So that's just for the message. If I dot is numeric, so if it's a numeric value, then we're going to do if add in to do, so if it's or plus, so this is where we're just saying what words do what, then we'll do num plus equals whatever that value is, int I. Elif sub, in sub will mean subtract or subtracted, or minus in to do, then num minus equals int I. Elif, yeah, we're pretty much just going to go through all of it, times in to do, or I guess you'd have multiplied or multiply, so multipl in to do, because I've done in, which means that if I had 5 multiplied by 6, or multiply 5, or 5 multiply 6, then it will just have multiply, and it will find either of them. So that's probably the best thing I can do there. Then we'll do num equals num times int I, else will now be elif again, divide in, so that will cover divide or divided in to do, and int I, oops, because we don't want to divide by 0 because that will create an error, so I is not equal to 0, don't want that. Then we will do num equals num divided by int I, elif int I is not equals 0. Then we'll do output equals I cannot do that. And I know it's controversial to break inside a loop, but it's just easy right now, and we all know the only reason this loop breaks is because it's gone through all of the elements, or just I cannot do that. I could use a while loop, but then I'd have to define all those values. So if it's not a numeric value, so else to do equals I. So that's, if it's not a numeric, then it's got to be an operator, because that's what it's stripped it down to. And after that, we'll do if output is not equal to I cannot do that, then we'll just do output plus equals is, and then plus str none. So let's play around with that. Let's see what happens. What is 10 divided by 2? It's 5. What is, oops. That should be that. Okay, so what is 10 add 3? 13. So as you can see, we've now added maths to it. Then the only thing after that is calendar. Now that one's a bit longer, and I don't have internet at the moment, so we won't be able to really test that out as this moment, but tell you what, we'll write it out and then we'll try it when my internet's back. So where were we? Here we are, calendar question. Now the calendar is going to be, we want to gather the months, we want to gather the days and the years. You might not always specify all of them, so we may need to assume some of them. So if we get a default year equals date dot today dot strf time, and we only want the year, and then we'll do the same for the month, because if you say what do I have on the 30th, you probably mean of that month. So month equals the month, we get m. Now we'll get us the number of that month. For phrase in the BD broken data, and then we're going to go for I in self.months. Remember, we created the months at the beginning. We're going to loop through each of the months and then do for I in. In fact, we'll shorten that because I can't be bothered to type that out every time. Yeah, for I in phrase. So m equals str.self .months .index, and then I. Then we will do, but we want to index, so yeah, index I, and then I guess we want it at just at position I. So this means that we'll get the number of the month, and we want to get the number. Sorry. So if we get the index, and it's going to index, so January is at 0, but it's the first month. So we want the first one, and then in fact, yeah, that should be a string. There you go. So we'll get. So if we have a month that is so say position I in phrase is a month. So yeah, that shouldn't be that should be if. So if I in phrase, no, I've done something very wrong here, haven't I? So I in phrase, So we're going to loop through. Oh yeah, so we're going to get each month. Sorry, I had a bit of a moment there. So yeah, this is going to loop through every phrase. So what is, and then the capital, and then of Germany as an example. So then we're going to have what, or for I in self.months. So that's just going to go for each month, January, February, March, and so on. Then we've got for I, if I in phrase. So if January is in that phrase, then we're going to get the month at January. It's going to be 0 plus 1, then it's of the first. And in fact as well, we'll want to, because it's a string, we'll want to have, so we'll get to that later actually, yeah. Then it's if the length of the month now, so if it's just the first, equals 1. So everything's done as 0, 1, 0, 2, and then up to 0, 9, and then it's 10. So you only have 2 digits. That's how the library works for the calendar. So we'll do months dot append, and it's going to be 0 plus month, and then we can add what month it is. Else we'll just do months dot append m, because it's a 2-digit number already. So we've done that. We've found all the months. Now we're going to do for word in phrase dot split, and word equals word dot replace the first. So if it's like the first of the month, we don't need the first, we just need the number. So first with nothing dot replace the second with nothing dot replace the third with nothing, and dot replace the if of the date. So that will cover all numbers, I believe. So once we've got that, we do if word dot is numeric. This is all we really care about. Then we will do well, I guess if it's numeric, then we'll want to, that means it's a day. So we'll have 2 different places. So you can have a word which is, a number which will be, the 1st of February 2002. You also have 2002. So you want to distinguish what's the year and what's the day. Now, of course, it could get confused. If you were to say the 1st of the 1st of the 22nd, then that's sort of saying, that's once again, it's getting complicated because natural language engineering is complicated and it will require a more complex model. But this is just a simple AI, so we will do, so it's numeric, then we'll do if the word, the integer version of that word is less than or equal to 31. So that's a good chance that it's a day. And then we'll do days.append and word. Elif int word. Now, of course, you could easily break this. I haven't added any validation. If I said what was -5, then that will break it. But I guess that's just for the coder to work out. So we'll do years.append and word. So down here we'll have, so now we've looped for all of it. If years equals nothing, then we'll do years.append default year. So this is if we didn't specify the year, because we start seeing what's happening next Tuesday or something, then the year is implied. Then if we do if the, we're not doing an elif because we might be missing a month as well. If the length of months equals 0, so that's the same as it being empty, then months.append. So this is going to append the default month. So once we've done that, we can do if today, today in message, and the length of days. So this is no day was found because I said today. Length of days is equal to 0. Then we know that days.append. In fact, we could do a default day, couldn't we, as well? Default day, and we just want day. So then, where was I? Default day. Cool. So next, we're going to actually try and get that. So try tasks equals self.calendar dot get day. Then we'll do days, because we want to get the day, and now we're going to put in the string that we want. So have days at 0. We're only going to find the first date that we want, plus months at 0, plus years at 0. So if you say what's happening on this day and this day and this day, we haven't really prepared for that, so we're just going to we'll gather each of the dates. But in fact, for now, we could also just print out what is the date that it's found in our sentence. So we'll just do accept and then pass for now, because it's going to give an error. So calendar, what is the date today, will give us the default year is not defined. Default, let's have a look. What line is that then? That's line 143. So we've got default. Default year is not defined. I think you'll find that it should be. Yeah, I misspelled all of them. Okay. What is going on today? So it's the 21st of the 1st of 2021. That is correct. What is happening on the 45th? Not 45th. The 25th of March. Okay, so now we've got index out of range. So let's work through this. So which one's out of range? Because if there's nothing there, and it should find a day through here. So let's have a look. We're getting the phrase, we're getting if it's less than or equal to 31. Well, it is, so it should append that to the days. What part is out of range? Because it will be day, won't it? Just double check. And why has days not got anything? Because it should. Yeah, so it's days. So let's have a look. Why has it not appended? Print word. Surely it should find it. So it's not finding it. Why is this? So we're going through the phrases in the BD, the broken data, going through the months, and then we're going through the phrases. Oh, I see. We need to move these back. That was indentation. See, there's always something silly. I should have twigged when it printed that out 3 times, but my bad. So let's have a look now. Should give us the 25th of the 3rd of the 2021. Okay, it doesn't. So month, what do you mean? Chatbot has no attribute month. No, it doesn't. That's right, because it's months, isn't it? What's that here? Alright, now it should give us, but it's not going to. There we go. 25th of the 3rd, 2021. And also, I'm sorry, I can't help because I haven't added anything to it. So there we know that it gives us the right date. So that's where we will write in the get from the calendar. So we want to get, so firstly what we've done, we've got the date in the format that we want it. And then we will just want to gather it. So we've got the task, and then we'll do output equals you have, and then for I in tasks, we'll call it something meaningful, task in tasks, and we will just pretty much do output. And by the way, the calendar returns it in the form of a list or a 2D list where it's task and the time that it is. So we'll do output plus equals task at 0 plus at, so you have this task at time task at 1, and then we'll just do a comma and the next one, and we'll do if output. So this means that if there was nothing, so if output just equals you have, then that means nothing was found, and we'll just do output equals or plus equals have nothing on that day. So that will calculate what I have on a certain day, and if I've got nothing, it will just say you have nothing. So that is the code all written. So let's run it. I should have Wi-Fi back now. So who was Winston Churchill? Okay, I can't help with that. So the Wikipedia is not working. We need to fix that. What do I have on the 26th of January? Sorry, I cannot help. So at the moment, it's a bit crap. But let's see, why isn't it working? So, oh yeah, we haven't actually defined calendar because we took it out. Let's put calendar back in. You have machine learning at 12 o'clock and computer vision at 17 p.m. So that works. It tells me, what do I have today? You have a strategy lecture at 8 o'clock and feedback at 8 o'clock. Okay. What do I have on the 22nd? Sorry, I can't help with that. What is going on the 22nd? Okay, I can't help. Is going on the 22nd of January. You have a power meeting at 5 o'clock. So it tells me what's going on. I'm trying to find a day that I'm not doing anything. What is going on the 23rd of January? You have nothing on that day, finally. So there we go. I guess that's Saturday. I've got nothing. So that all works. So now we want to work out why isn't the Wikipedia working. So where was that? That was just question. So if it's a question, it should try and get the Wikipedia summary. And so print, we'll have a look at the subjects. Who was Winston Churchill? So yeah, it finds the subject. Oh, and it found it. 53 lines. We will get dot split at, and then get the first position. So we'll split it into sentences and get position 1. Who was Winston Churchill? Okay, don't have a list. Yeah, that's right, because that's not the right place. This is the right place. Here we go. Third time lucky. Who was Winston Churchill? So Winston Leonard Spencer Churchill was a British statesman, army officer, and writer. Cool. What is a turtle? Purple refers to any of the variety of colours. So it thinks I've said purple. That's what the Wikipedia library does if it can't find what turtle is. Maybe I spelled it wrong or something. What is a dog? So warning, the code. I'm sorry, I can't have it. So I think that means that it couldn't find it. So it gives a warning from the module. Okay, so if I still have some bits, what is time? Yep, that still obviously all works. We haven't changed that. What is your name? Still uses its own. What is your age? That was made on the 21st of the 21st. So there we go. I hope you enjoyed. I appreciate it's been a very long video, longer than I thought it was going to be. Thank you for sticking with it. It's okay if you didn't, or you just skip to the end to see what it's like. Try it out. I'll also put the code for download, and this video is always there if you want to find out why did I do this bit, but you don't want to sit through the entire video. So yeah, thanks for watching, like and subscribe, and hopefully next time we'll be moving on to a more complex chatbot.